All right. Hi, everybody. My name is Tim Whitley. We're at the Human Resources Science Group. We're happy to have Robert Kelly and Jack Keeton today here talking about building their own AI apps. I think this is a really awesome topic and obviously very relevant for what's going on today. Um, just a real quick plug, our group is putting together a survey to try to find, kind of what resonates with people and what's going to be interesting to them. So I'm going to put that into the chat. If you have a chance to fill that out, I'll put it in at the end as well. But this is also a way if you want to get notified about future events. Where Melissa and I are working on a um, newsletter. So we're also actually looking for people that if you're interested in writing short snippet articles for the newsletter to let us know. But yeah, you can sign up here and get on our newsletter list and find out about future events. So with that, I'm going to turn it over to Robert and Jack to introduce themselves. Thank you.
Thanks, Tim. Yeah, let's do a quick intro. Then we've got a deck prepared and some demo stuff. So my name is Robert Kelly. I'm an HR consultant. I've been in HR for 15 plus years now. I mainly do HR data, HR technology implementations, and a lot of comp, and mostly in the media and entertainment industry. So we're happy to talk about AI today. I'll let Jack introduce himself too.
Hi, I'm Jack. I've been in HR for all of 2 years. I'm currently an HR data analyst at the Walt Disney Company, although I have to say, this does not reflect any of the Walt Disney Company's views. This is not a Disney AI. They're not affiliated with this. This is a personal, me showing up as an HR professional. So really excited to be here.
Cool. All right. Let me go ahead and share screen. We've got a little presentation prepared. Can everyone see that? Thumbs up. Okay. All right. So we're going to talk about open source AI today, and specifically how we think it fits in the AI for HR puzzle. And we're going to cover a matrix that we put together kind of to help guide a sort of like a framework for how to think about adopting AI solutions for HR. We'll talk about open source versus proprietary AI models and what models are. We'll then talk through a couple concepts that we think are important to understand in the natural language processing toolkit. Then Jack's going to take us through a case study, which is a real open source AI app that we built to solve an HR problem. And we'll sort of wrap it up with how open source AI is like a perfect fit for HR and make a pitch for using this. And if we have time, then we can also do a demo of the app that we built, but we'll just kind of see how it goes. Okay, so let's look at this matrix. So this is a framework Jack and I developed for how to think about adopting HR AI solutions for HR. And the way we think about it, and I'll say, like, I think we think this is probably directionally correct, but as we all know, this is a very fast-changing world. So maybe not exactly over time correct, but probably directionally correct. So let's talk through this, right? So if we plotted out how specific a problem is, right? So like an HR problem, from more generalized to more specific on an x-axis. And then we intersected that with a y-axis that plots how generic or sensitive your data is that you're putting into an AI solution on a y-axis. We think that kind of cuts solutions into 4 quadrants. So let's talk through those quadrants, right? And this is kind of like the sort of like decision set framework for how to build a tool for HR. So let's start in the top left, right? So this would be generalized problems, and think about that as a tool that has a lot of users that are using the tool for a lot of different use cases. And this would also be generic data. So what we mean by that is like this tool can ingest any data that is not sensitive, right? So we wouldn't put sensitive data into this. It would be more like generalized data. right? And a perfect example of this that we've probably all used is ChatGPT. And we think about this quadrant as AI via a public website, so accessible to really everyone. So ChatGPT is a perfect example of this, right? So it solves generalized problems, right? So I might use it for, writing poetry. Someone else might use it for helping them write code. It's going to do a ton of different use cases. But because it's hosted on an external server, we have to be really cautious as we think about HR applications about what data we would give to that. So you couldn't, for example, give ChatGPT, or you shouldn't give ChatGPT like personally identifiable information, right? So generalized problem, generic data, AI via public website, right? Down below that is AI via private cloud, right? So this is, again, probably going to solve more generalized problems, right? So they'll have a lot of users doing a lot of different things with these AI tools. But because it's in the confines of a private cloud, so we have kind of a gate around the model, now we might have unlocked the ability to send sensitive data. And a good example of this would be like Snowflake AI, right? So if we have a Snowflake database that holds our HR data, they might offer an AI tool on top of that data, again, sitting in a private cloud, so we can be comfortable sending more sensitive data to this AI solution, right? But it's going to be delivered for a lot of users and probably used for a lot of different use cases. And this whole left side, by the way, is sort of our buy solutions, right? We think of the whole right side as like more build solutions, right? So these are things, again, because they're going to be serving a lot of users, that we generally are going to go to a vendor for and buy them, right? And then implement them. Everything on the right is going to be more, we're going to build it from scratch, right? And why is that? It's because if we move to the right, we're looking at more specific problems. So like hyper-specific use cases, right? And so let's go to the top right now. So in the generic data, hyper-specific or more specific problem set, we're going to have solutions that are AI via APIs. So this might be like something like a ChatGPT wrapper, if you've ever heard that term, or a good, hypothetical example in HR would be like a weekly HR newsletter, where we can give this generally more generic data, but it's doing something that requires code to build, that's solving a hyper or more specific problem. So this weekly HR newsletter example would be like, you might have to send out like a weekly like blurb to your HR organization of like what's going on in HR this week at our company, right? Generally speaking, that's more generic data, although there might be some sensitive data in that of like what's going on in your company, but it's more generic data. So you can probably send that to an external vendor to run in an external model. And then that can, like, let's say you sent bullet points, that can then be ingested by the AI, written out as a full newsletter and sent back to you via the API call to go ahead and publish to send out, right? And you could even like wrap code around that to like format the newsletter and things like that. So more specific problem, but still generic data, right? And then the last quadrant, which is more what we want to talk about today, so thanks for the patience, is local AI. So this is going to be sensitive data and specific problems. And the tool we built that we're going to talk about today is a good example of this, which is a tool that solves a compensation problem. It ingests a job description and tells you a survey match when you're leveling a job. Most of the local AI quadrant is also going to be open source models, right? So these are models that you can go onto the internet and download, that are offered by open source labs or companies, and download and manipulate locally on your computer or your local server. So let's talk a little bit more about that, plus some additional sort of background concepts that we think are really important to understand as you think about how would I build different things in these quadrants and adopt different solutions. Some of this information is kind of like the puzzle pieces that you have that you can kind of piece together to figure out, all right, what solution can I build and what can I adopt? So the first thing we want to talk about is, what is an AI model? So this is probably like obvious to most people, but we'll cover it anyway, because it's really important, right? So when you think about an AI model, what it really is just a huge file that contains a ton of numbers that represent probability weights. Now, of course, this is a little bit of an oversimplification, so there are more technical details involved, but it's probably about like 90+% of the answer to what is an AI model. And you can visualize this, right? Just think about like a big Excel spreadsheet, right? And in that spreadsheet, there's rows and columns that are just filled with a ton of numbers, right? And like a really, really big spreadsheet. But you can think about a model as just that big spreadsheet and all those numbers in that spreadsheet, right? It's kind of as simple as that. So let's give like an example of this using something that I'm sure all of us have used. So we probably all use ChatGPT. And when you use ChatGPT, you're using a model and you're giving it a prompt, something like the weather in Phoenix is. And ChatGPT is just using that model, those weights, that big Excel file, to try to guess the most likely next word after is, right? So when you give it the weather in Phoenix is as your model input or your prompt, you're using that big Excel file, or it is using that big Excel file of numbers, which run through a big neural net, right, to find the likelihood of the next word in its dictionary, right? And so to take two simple examples of words in its dictionary, we can see hot and cold, right? So as it goes through, it assigns a probability of the next word being hot and the next word being cold. And of course, we know Phoenix is more likely to be hot than cold. So that's going to be the higher probability. But the model itself is just this big middle part, right? That's this is big Excel file full of numbers. And that's like the core component of an AI model and a super important concept when we think about the distinction between open source and proprietary AI, right? So what are those things? Well, the defining characteristic of open source AI is that those model weights, that big Excel file, is freely available for local use and manipulation. So said another way, you can go to the internet and download the model to your local computer and run it locally. You could like open the Excel file up and see the numbers themselves. Whereas a proprietary model sits proprietarily in an external server, and those model weights are protected and guarded, and it's a trade secret, right? So open source means you can see the Excel file. Proprietary means that's locked down, and you have to simply send your prompt, the weather in Phoenix is, to an external server, and then it returns an answer, right? So you don't know how the answer was received. Okay, so some examples of open source models. Well, the kind of leader here, and they certainly don't only do open source models, but they are the leader in open source, is Meta AI. So you guys have probably heard of Llama, the Llama class of models. Llama 3 was just released a couple months ago. But Meta has really been leading the charge among the major tech companies for open source. So we can all go and download Llama files from Hugging Face like right now. But there's a lot of other providers too. So one that we use, so we put them on the list, is Mistral AI. We use Mistral in our case study, which we'll walk through in a minute. But there's literally like tens of thousands of open source models and hundreds of providers. It's research labs, universities, companies, nonprofits, et cetera, right? And Hugging Face, just as sort of a plug for Hugging Face, is like the place that these models are stored on the internet. So if you want to go kind of look through open source models, go check out Hugging Face and you'll see like tens of thousands of them. Okay, so why would you use open source, right? Why wouldn't you use proprietary? And we'll talk to proprietary in a second. Well, the main reason is what we've sort of already mentioned, is that like you can download the file and run it on your local computer with no connection to the internet. And why is that important? It's important because of data privacy, right? So again, as HR practitioners, we deal with a lot of sensitive data, right? And I'm sure all of us have already heard the warnings about, sending data over to OpenAI or Google or Anthropic or any of those proprietary providers, because what that means is your data is literally leaving your computer, traveling to an external server, and then the AI is sending a response back, right? So if you send social security numbers, that's obviously a problem and not something we should be doing as HR practitioners. Whereas if you use an open source model that's running on your computer, it's no different than having an Excel file with social security numbers. Now, of course, you want to be careful about that, but you can now use AI on top of PII data which gives you a whole new set of use cases. Going back to that framework, you can now use sensitive data in your HR AI solutions. Whereas for proprietary, maybe you have to be a little bit more cautious about doing that. So data privacy is kind of the headline of why you would use open source, is you can send AI any data that you want to, right? But there's other reasons too. So they're generally lower cost. So you download the models for free. That's a high characteristic of open source. But you also, when you run the models, you don't have to pay API calls, right? Or you don't have to pay a membership to use ChatGPT, right? So it's free to download and free to use. There's no marginal cost. So if you have an idea in mind for a tool that's going to have a lot of users or a lot of use, it's one consideration that open source is going to give you a lower overall cost in building. And then the last thing is that they're more flexible. So open source allows you to piece together different models. I talked about the tens of thousands of models on Hugging Face. A lot of those are optimized for very specific use cases. So it might be like your SQL coder AI, or it might be something that is really good at scientific knowledge and research, right? So you can take these different models and piece them together a little bit more easily than in the proprietary ecosystem. So you get a lot more flexibility. And again, if we think about how specific your problem is, if it's a more hyper-specific problem, this can become very useful as you build solutions. But there's reasons also to use proprietary, and we've probably all experienced them. So leaders in proprietary, of course, ChatGPT, OpenAI, they're like the big one that started the whole revolution. Google Gemini is getting super impressive now. Anthropic with their Claude class of models is also a really great set of proprietary models. And what do all these have in common, right? Not only are they proprietary and the weights are kind of locked down, but they're more performative, right? Just generally speaking, proprietary models, because people pay to use them, have to be more performative, and they are. We did a quick look at a benchmarking leaderboard for LLMs, and 11 of the top 15 performing models, were proprietary. And again, it all makes sense. People pay to use these, so they should be the most performative. But generally speaking, you're going to get a bit of a performance boost when you use a proprietary model over an open source. So that's like the headline reason to use them. But generally also, they're a little bit easier to use, right? Again, makes sense. You pay to use them. They should be easier to use. But they have the chat interface already ready. You don't have to write any code, generally speaking, to use them. A lot of times they're multimodal, so you can not only give them text, you can also give them images, audio, they can create pictures, things like that. So again, makes sense. You have to pay to use these. So they should be more performative and should be easier to use. But the big drawback is that you have to expose your data to the model in order to get a response back. So that's the big differentiation between open source and proprietary. And what we built today, what we're going to show you in a minute, is an example of open source. So before we get to that, though, let's talk a little bit about the natural language processing toolkit. So we think natural language processing AI, which is language AI, is just a really compelling case to be adopted in HR. Talk about this a bit more at the end, but we have a lot of unstructured text data. So natural language processing, rather than like diffusion, image generation, video stuff, is really where we see like the most early adoption with HR AI. So let's go over a couple key concepts in the natural language processing toolkit. So things that, again, as we think about those AI puzzle pieces that we might piece together to make solutions, these are three things that we think are really important to know that are in your toolkit. So the first is one that we have all used, whether we know that it's called inference or not, but LLM inference is what is happening when you use like ChatGPT, right? It is simply said running an AI model. So you send a prompt, going back to that earlier slide, it goes through the neural network. That is called running inference, and then it sends you the response. So we're all familiar with that, but important concept. But two that maybe you're not maybe as aware of, or we want to explain at least in a bit more detail, are LLM fine-tuning and embedding. So fine-tuning is when you take an existing language model and you gave it new data and you give it a bunch of examples of how to do a specific thing, and you teach it how to do that specific thing really well. So fine-tuning is existing model, bunch of new examples, and it gets really good at doing the examples of that specific thing. And this is super useful if you, again, get to the right side of that framework where you have more specific problems, it's doing one thing, and you can teach it to do that thing really well. All right, so that's fine-tuning. Embeddings is when we take words, right, and we encode those words as numbers, which can then be compared semantically to find similarity. So that was a lot of word salad. Let's actually look at this in an entire slide, because we think this is a really important concept and a huge unlock as a tool that we have just in our daily toolkit, right? So let's talk a bit more about what embeddings are. So embeddings allow a computer to understand words by turning them into numbers, right? So you can give them any word, set of words, string of words, paragraph, and it will encode those into numbers. So like, let's take a familiar example to kind of highlight what we're talking about here, right? So on the left, we have something that all of us are going to be familiar with, right? So let's take a map, right? And let's take some cities in the United States. If we were to take those cities and encode their location into numbers, what would we be left with? Well, we would be left with their longitude and latitude, an XY coordinate, right? And if we then took those coordinates, those longitude, latitude, and compared them against each other, since they're now numbers, a computer could tell us how far a city is from another city, right? Because we can compare the longitude, latitude to see distance, right? This same concept of taking a location and turning it into numbers can apply in LLMs when we take words and turn them into meaning, right? So in the example on the right, this is a plot of embedding numbers, right? And these are simply words that the computer has embedded into numbers. And so like, if we were to take a couple words on this plot, right? So let's take kitten and cat, we can see that those vectors, which is how an LLM turns words into numbers, are really close to each other, which implies that they have a really similar meaning. We all speak English and can tell that that is the truth, right? A kitten is a young cat. Whereas if we compare kitten to banana, those are really far from each other. And that makes sense also. They don't have a similar meaning at all, right? So just like we use longitude, latitude to encode, location for cities, we can also use embeddings with an LLM to encode meaning for words, and then compare those meanings to one another. And why do we think this is so important? Well, essentially, if you kind of step back and think about this, this introduces what is essentially Google search to all of us for any data that we may have, because we can give any unstructured text to an embedding model and then compare the distance between the encodings and find out similarity between two things. So hugely powerful tool as you kind of think about different solutions on that framework. This is a really important tool and a really powerful tool in your toolkit. So embeddings are a really cool concept. So, okay, now we've covered some of these concepts. Let's kind of maybe step back. Jack, maybe you can take over and walk us through our case study for how we put some of these together.
Yeah, for sure. So this is kind of the fun part, is where we're going to put everything that we just mumbled on about for the last 26 minutes and into something maybe a bit more tangible. So don't worry if you've been lost so far. Hopefully we can get you back up to speed. So our case study starts with a really simple question, and that's, can we build a tool that can find a compensation survey match for a job description, right? Just one sentence, really easy. And we broke it down into 3 parts to handle this with a fair amount of accuracy. The first thing is that we need to fine tune a model to extract responsibility, skills, and experience from a job description. Job descriptions are great, right? They're almost like marketing to try and find new people, but that same thing that makes them great and appealing, like, ESPN is going to talk about sports in their job description and go on about, things that are specific to ESPN, are really bad for a model, because we don't want that fun stuff. We need really just, the nitty gritty. What do you do on a day-to-day? How much experience do you have, etc. So what we did is we create a model that learns how to do this and just to extract that core data out of, these job descriptions that, again, they're beautiful and attractive, but they have too much in them and we need to really condense them down. And then our second step is embeddings, just like we talked about. We encode the information from a job family and the level, so like manager, VP, etc., and compare it to a survey, basically. And an important distinction on this second step is that on the previous slide you saw, we were comparing words. And that's how this all started. It was really smart. And it was only like maybe a decade ago that some researcher figured out that they could do this. But it's gotten to a level now where it's not just word to word, it's sentence to sentence, paragraph to paragraph. You can almost compare entire documents to each other. So just take that, word to word comparison and expand it to like massive levels. And that's what we're doing here. And step 3 is the user confirmation. And this is the most important part. We can build the most amazing model in the world that does everything you want, but we always kind of need that human input to confirm that we're doing the right thing. Because occasionally you come across a job description that's maybe not well written, or the title tells us nothing. It just says compensation, and that's it. And we need a human to help us find what is real and what is the best fit, because the models only got what it's taking in, garbage in, garbage out. So the human helps us sift through a bit of that.
Can I jump into, I just want to, for anyone who hasn't done comp, like describe how a human does this, right? So what we're trying to replace in a little bit more detail, right? So like if you've ever done job leveling or compensation survey submission, what this task is like you get a big repository or even just a single job description, right? And you have to read that job description, and then you open a compensation survey, which has hundreds of jobs and hundreds of job descriptions listed. And you essentially have to match the job description you were given to the best match among the huge list of compensation survey jobs, right? And so what a human does is they like read here, right, with the one they were given, and then they like go through and filter and read and compare and repeat and repeat and repeat, right? So this is a very manual human process. If you haven't done this process before, it just takes a lot of reading and comparing and time. And that's kind of like what we tried to attack here. So if you haven't done comp, that might not be super clear. So just want to jump in.
Yeah, that's perfect. And I think it, again, points out the use of this. We're not replacing anybody. I mean, hopefully not replacing anybody. This is just going to make people's lives easier, and so that they can focus on things that are going to make a real impact in their business, hopefully. So here's our example. We'll start on the left, and this is a job description for a software or data engineer at Snowflake. And you can kind of see what I'm talking about. You don't have to read through the whole thing, but it's talking about Snowflake's history and, what does it look like at Snowflake specifically, but then it talks a little bit more about, what you do in your job, the ideal candidate, the things that we're more concerned about. So you can see if we fed this to a model just raw, it's going to get pretty confused. So what we do is that we extract our structured info in a standardized way. So this is where Mistral, that open source model that Robert was talking about earlier, comes in to extract responsibility, skills, and experience. And you can see the prompt that we're giving it. It's pretty simple. Just what is or are the, let's say, responsibilities listed in the following job description. And so it's going to do the reading part and extract that for us. And then the second step is that we get a job family prediction. Again, using Mistral, we give it a different instruction and say, all right, now that you found responsibilities, skills, and experience, what's the job family? We don't tell it, choose from these 100 job families. We're just saying, use your, not experience, it's not a person, but your idea of what job families are and just give us one, right? It'll get basically ballpark to what we need. So what specific job family might have or require these job responsibilities, and the job family in this case would probably be software engineering. Now we get to take the structured data that we just got out, which is great and clean, hopefully, and compare it to our compensation on the right. So you can see, there's parallels. Job family on the left, survey family on the right, level info on the left. So manager, professional, etc. Survey levels on the right. I mean, it makes it really easy to compare now, whereas if we just threw in the job description at the beginning, it would not be able to parse out as well. And so we feed it to something called Angle embeddings. It's just a name of an embedding model. Again, open source. This is just something that was developed by some researchers at a university. And those embeddings are just giving us our location or coordinates, right? Just like on a map, we're just finding out how close are each of these things, one job description to all of these surveys. And then we get a similarity score, closest gets the highest similarity. And then it gets fed to the human verification layer, highest similarity first. So first thing that pops up, let's say it's something terrible, marketing. The human goes, nope, that wasn't close. Give me the next most likely. And we filter through until we find a match. In this case, it'd be some engineering job with a market survey and a salary range.
Cool. So I think we went through that relatively quickly. So we probably do have time to actually see a demo if people would be interested in seeing this tool in action. Does that sound good?
Sounds good.
Yeah. Okay. Let me.
Hey,
yep.
I had a question real quick. So you do that human verification, and they said, no, it's not marketing. Yes, it's this. Do you use that then to improve the model? Is there kind of a cycle there?
We could. Absolutely, we could. Not right now, because we just sort of wanted to get a viable idea out there. But you could take its failings and fine tune it again to give better job families probably and better responsibilities and skills and look a bit larger. There's always going to be weak points, always going to be blind spots. Sometimes it's just a bad job description, but we could train to be a bit better. And then I saw Kyle in the chat had a question. Are there cases where the tool would suggest multiple job families, or does it force pick one? This is kind of yes, kind of no. It chooses multiple job families, I guess, by just ranking them almost, but it's always going to suggest one at a time, right? It's not going to say, is it one of these two? It's always going to be like, is it this, yes or no? And then move to the next one.
Yeah. And it's designed to find at the end of the process, and you'll kind of see this in a demo, it's designed to land on one match, right? Now, that's mostly because it's separate from the AI model itself. The AI model is agnostic to that. That's mostly the rest of the Python that we wrote to land on one. So you could modify, the programming to just hey, I want it to take 2 matches or 3 matches. I'm going to blend this. So it could be either, but the way we built it was just it lands on one exact match.
Okay, but that's a great point. Are there any other questions? I know it's a lot to cover. There are no dumb questions. I promise. I've had plenty myself.
Did you all you said you use Python and stuff. Is that something that you all were are you Python experts enough to do that yourself, or did you get AI help to help you with the coding? Because I personally have done a lot and I use AI because I'm definitely not a Python expert, but.
Yeah, let me start with that. So I started learning Python in about a year and 4 months ago. And the reason I'd always kind of had it on a list of I should learn this. And the reason I took the leap and started learning it was ChatGPT came out and it was easy to learn at that point. So my background's HR. I'm not a programmer at all, but with ChatGPT or whatever proprietary model you use, I mean, the speed at which you can pick up, Python or any other language is in my experience, just incredibly fast now. So I would say you don't need to be a programmer to piece together anything on the build side of the framework, right? You can just use a language model as long as you know the concepts of what you're trying to do to give you the detail and the actual, physical code to write. And kind of going back and forth with it to piece things together till they work. Honestly, the hardest part of learning Python for me was figuring out where to run it, which is, you can use Spider or VS Code. But there's a lot of resources on that too, and ChatGPT helped me work my way through that. But actually writing the code, candidly, is just me thinking in, natural language terms, and then ChatGPT turning that into code. So I guess the pitch here is it's easier than ever if you want to pick it up.
And I have a separate perspective. I went to school programming. I am more of a programmer, but it doesn't mean that I knew how to do any of this. It doesn't get taught. Obviously, I think curriculum lags a little bit behind this really fast moving technology. So I also, outside of work, use ChatGPT to help me understand what's going on. And I can read the code it creates, and it helps me just learn a lot faster. So basically any experience level greatly benefits, not just beginners.
Okay, let's take a look at the code. I'm going to turn my camera off because it's GPU intensive to run this. But let's actually start with the input.
This is going to look overwhelming, just objectively.
Yeah.
It's a lot of words. Don't worry about it.
Don't worry about this.
It's
code.
not as complicated as it looks. I think code was made to look complicated for some reason. I don't know who thought of that, but it's easier than it looks.
So, okay, so let's take, I have sort of this queued up, but this, I promise you, is just random jobs that we pulled off of LinkedIn. But these are real jobs that were posted. So this is sort of our input to the process. So we're taking real jobs from the wild, and you can see in this column, as you kind of look through here, they're just these really long, unstructured job descriptions or postings that have information about what is being done in the job, as well as information, as Jack mentioned, about the company, its history, legalese, things like that, right? So all of that separate stuff is, we think of it as noise. And as Jack kind of walked through, the first step is taking all of this really kind of unstructured, language in the job description and extracting out the things we care about when we go to make a survey match, right? And so the three things that we care about after a lot of trial and error are responsibilities, skills, and experience. So we give the first step, which has already happened at this point, is giving the fine-tuned language model this big blurb, which is the full, job posting online on LinkedIn, and saying, just extract out in a structured way the responsibility, skills, and experience. So that has already happened. I won't make you guys watch that part. So that has already happened at this stage. So we've already done step one. So this is kind of our starting point of the demo, is we want to now match these 6 jobs to their correct survey match, right? So this is what's going to go in. So that's why we're starting there. So in order to do that, we'll run our program, which is our matcher program, and you guys can kind of see how it works. So this uses a console UI. It is truly an MVP, a 0.1 version, because there is no GUI. So the user experience is a bit old school. But essentially, all we're doing is first importing that data file that we were just looking at. So those jobs and the responsibility, skills, and experience data from Excel into the program. We then do a fuzzy match. We didn't really cover this in the deck because it's a really small part of the process, but all that does is it looks at all the job titles, and anytime there's essentially an exact match between the job title and the survey, it's gonna say, okay, this is an easy one, just take that match. We don't need to look at the actual description. We're just gonna kind of lock it in to the exact survey job. Someone might disagree with that as a practice. So, certainly doesn't have to do that. It's just a way to cut down if you had a large number of matches, if you were matching, your entire organization to a new survey, you might want to do this just to speed things up. So the next section is then what Jack described, where a base LLM predicts a family, right? So it reads the responsibilities and skills that are required in the job description that we extracted. And then the LLM makes a prediction for what family do those responsibilities and skills describe, what job family. So it does that for each of our jobs that we have remaining. In this case, we were able to fuzzy match 3 of the 6, and then we have 3 kind of quote unquote hard ones that need to go through the longer process. So that family prediction gets us something like, like software engineer. We also ask the LLM to describe in like a sentence, what does a software engineer job family do? And the reason we do this is so that when we get to the embedding step, which we're about to get into, it's much easier to do an apples to apples comparison. Again, we want similar length text, similar number of words for the embedding to work the best. So now that we have those family predictions, this is where the user comes in and has to be involved in overseeing like the end of the process. And we're going to break this up into finding the family on the comp survey first, right, for each job. And then separately, we're going to loop back and find the level match. And at the end of that, we'll have the final survey match. So let's see how it works. So I, the user, I press enter. Yeah, let's go. We're ready to do family matching. Embedding model loads. This is the part that's computationally intensive. So right now, what it's doing is it's comparing the job family information in the individual job we're looking at to all of the family information in the survey. And then the user gets a prompt for, hey, I need some oversight. I need you to confirm something. So what's happening here is we've got a single job that we're trying to match. This was from our original list. In this case, it's a senior director job at Google that oversees YouTube TV and primetime, whatever that is. We see from the previous step that we had just looked at that the LLM predicted a family of product management, and then it gave a brief description of what it thinks that is, right? From the job description, we'll then show the user the responsibilities that we found in the job description and the skills that were required. And if you kind of just eyeball these, you can see some things that do sort of suggest product management, right? Especially in the experience, product initiatives, ecosystems, things like that. So already as a user, I kind of have an idea that, yeah, product management seems to be a good fit. As I just eyeball responsibilities and skills, that seems to make sense. Down here,
Robert,
yep.
Sorry to interrupt. What survey is this that you're matching to?
This is using a Kroner survey. It's actually using 2 Kroner surveys, the digital technology and content survey, and I believe the entertainment survey. So it's kind of squishing those 2 into one. It's just to kind of increase the breadth of matches. But I'll also point out, so 2 things here. First, because this is running locally, we don't expose Kroner's job architecture to an external company. So again, sensitive data, so we have to run it locally. That's not our job architecture to share. But then the second thing I'll say is that it doesn't use a full Kroner survey result, right? So you don't need to give it comp information in order for this to work. It's simply the submission package, which is really more generally available. So yeah, but it's the Kroner surveys.
And so these descriptions that you pulled for the Kroner survey, was that public information, or is this from an actual survey?
These are the survey families that you find on the actual survey itself. And Kroner puts the families, on his website. Here, though, is from the job description that we found on LinkedIn. So it's sort of the example of how you would get a job description internally, maybe from a hiring manager or recruiter, and read it and then have to go find the Kroner match, right? So these are the Kroner families you'd be looking at, and this is the actual job you're matching up here.
So conceivably, if you were doing an actual survey submission, would you be able to upload the entire Kroner set of descriptions?
Yeah, the whole,
Families?
you basically could take any survey's submission package that you get as you're getting ready to fill out a survey, and load that into the system. We have Kroner in here. It could be anything. It could be Towers Watson. It could be Mercer. It could be anything, because really all surveys have leveling criteria and a family architecture. And as long as those two things are present, this will work for any survey. It's agnostic to which survey it is.
Got it. Thank you.
Cool. Okay, so getting back to the match, so the user is now seeing the AIs based on the embedding distances, 5 most likely family matches for this job. And then down here, we see the information in the survey of all jobs in that family that in the top matching family that exists in the survey. So the user has to take a look at this and say, okay, we are proposing product management as the AI's most likely match for this job. Just as an FYI, here's all the product management jobs in the survey, so you can kind of eyeball that. And now you're ready to input whether that's correct or not. So in this case, I think, yes, it is correct. So we'll just put a Y in and go to the next job. And the system will store that information to return back to the user at the end of the process as like a completed match. So we've got a couple more, and I'll show you just sort of like some other features of the system. So let's say in this case, we've got a new job, which is an FX job. Let's say in this case that the AI proposal for FX design family was not the one that I really agree with as the user. And as I eyeball the next most likely ones, I'm actually going to say, which I don't think this is really true, but I'm going to say, I want this motion graphics design family to be the match, right? So all I have to do as the user is say, effects design is not the correct match. I'll say no. And then the AI will cycle, the program will cycle to the next match, motion graphics design as the suggestion. That's the one I wanted. So now I can say, yes, that's the correct answer. And then the last thing we'll show is if you as the user are looking at the suggestions and kind of don't see one that seems to be a good match. It's like, no, these are all pretty poor fits. If that's the case, which again, really isn't the case in this one, but if that was the case, I can just, as a user, write skip. Hey, Kroner doesn't really have a match for this job. I kind of know the survey well. None of these suggestions are good ones. Let's just skip it, right? And it's just going to say, all right, we're not going to find a match. We'll just skip that going forward. Okay, cool. So we've recorded our family matches, and now we proceed on to level matching. This works really similarly to family matching. So you're going to get an AI recommendation for a match, and you're going to have to kind of say whether that's a good one or not. But it's a little bit different in that we already know the family, right? We've already gone through a match family for each of our jobs. So the leveling match will only look at levels within that family. And it will simply give the user all of the level options in that family and ask the user to pick from them, which is the correct one. So gone are yes, no's, and what we get presented with instead are putting in the numerical choice. So in this case, we're back with our YouTube job. It's a senior director. I can kind of browse, again, the responsibilities and this time experience to be like, is it really a senior director? I think it is in this case. So I'll look at my AI suggestion. This is ordered by most likely to less likely, and see, okay, the top suggestion is row 0, Python 0 indexes. So that senior director match is the one that I like. So I'll input a 0 and select that as my level match. Similarly, we get to the next one. I'll just pick the top one for time's sake. And then the last one that we had skipped, it's not even going to try and do a level match because we didn't have a survey match. So at the end of this, it then pulls together all of our information. We had a family match, we had a level match with those two pieces of information. the program is able to go into the survey and find the code and the job title, and then it will output an Excel file for you that just stores that information. So here I have my jobs that we started with, the survey code from the Kroner survey, and then the survey title and family and level. And the places where we don't see family and level, it did fuzzy matching. So, you know, you've output a labeled document that preserves all your progress. So that's the whole system. All right.
Robert?
Oh,
Oh, sorry, Lisa.
Go ahead, Andy.
I was just going to say, thanks for the presentation. This was so helpful. Question on the leveling. As it's currently structured, is it just leveling based on title or actual job description? Because, you know, oftentimes there's such a mismatch between what one person calls one level versus the other. And is there a human in the loop for that portion to be able to verify that it's actually leveled correctly? Just curious.
That's a great question. And actually, we tried a lot of different things to tackle this. So we, as purists, started with the job description and what was described to try to find the level. What we found is there were really two problems with doing that, which we're all going to be familiar with if you've ever done this as part of your day-to-day job. The first is that the writers of the job description oftentimes write the description in a way that will sound more
Or
advertising,
senior, or
right?
yeah. Mhm.
Yeah. So if you trust what they write, you often find things over leveled because, again, these go onto LinkedIn, are meant to attract people to apply to them. So that was a problem. We started to see like overmatching when we use that. The other problem is that people have very different definitions of what's required at each level. So like
Right.
one thing that we all eyeball when we do matching is like years of experience, right? Well, when you start to look at this at scale, right? So like lots of different companies, lots of postings, you know, across LinkedIn, you see very different definitions for what like a software engineer's years of experience should be. Some companies are going to say like 12 years, and some companies
Right.
are going to say like 1 year, right? And so it's not only like you know, you can't rely on it because of the advertisement. You also can't rely on it because like humans are writing these, right? And they have very different ideas. So what we ended up doing, what we found worked the best is to just look at the title, right? And that in itself is a whole separate problem because a lot of information gets encoded in a title, right? So there's information about what a person does, you know, software engineer. There's information about where they do it, you know, YouTube, TV, whatever company. There's oftentimes information about like the type of job. Is it part-time, full-time, remote? That can be squeezed in the title. And then there's level information, right? Senior director, right? So we actually had to use an embedding model to parse through the title itself to only extract information that tells us what level it is. And to do that, we made a big dictionary of like quote unquote level words, right? Senior, director, lead, manager. And we parse that, and then we take all of those and then parse the words in the actual title itself and only extract level words within the title. So keep senior director, get rid of YouTube TV, right? And then once we have senior director, we then compare that through another embedding to the survey level words to find the top survey suggestion. So a lot to say there. We certainly went in a lot of circles as we were developing this, but that's what we found gave the best result.
Thank you.
Robert, I have a quick question. So this Excel file that we see, is this the output or is this the input?
This is the output. Yeah. So the input was kind of the first thing we saw, which just to kind of highlight, it's going to be an ID for each job you're trying to match. It's going to be the huge description, the unstructured description, and then it's going to be the extracted responsibilities, skills, and experience. So the responsibilities, skills, and experience were actually the output of a previous step that I didn't show just for interest of time. which was a fine-tuned LLM that takes this raw description and extracts that responsibility, skills, and experience data in a structured way. So that fed in. We then did the matching, the user supervised matching, and this is the end result, which is really the survey match code and title.
Oh, so this is the output gets generated at the end of the task. So I know, so when you had uploaded, like there's the downward arrow. So so when you input, is it really an Excel file or is it a CSV file format that matters when you're uploading the data out here?
Yeah, so we have it load in as an Excel. It could be, a CSV. It outputs also, I think, as Excel. It could be CSV. It could be into a database. I mean, it's, like a line of code change. So it's just what we built, but you could kind of change this in a lot of ways.
Okay. And another question is, you talked about the open source AI for HR. So do we have like a list of what are those open source for HR and for what functions that they can be used? Like this is probably good for compensation. Do we also have something like for the other functions as well?
That's a great question. At this point, most of when we talk about open source AI, we talk about it and we think about it as taking open source models and then building your own solution on top of them, right? So it's taking, Llama 3 that you got the weights off of Hugging Face. It's then writing a program around, Llama 3 that does comp matching or something else. I think as like the space develops, and I have to be really careful because there's new stuff every 2 weeks. We'll see open source solutions that are more like off the shelf, adoptable. But at this stage, it's more open source model and then build your own solution. Again, that's why it points toward hyper-specific problems. So the lines will move on the framework for sure.
Gotcha. Thanks for that, Robert.
It looks like we're at the end of our time, so I wanted to be respectful if anybody needs to drop off, but just want to say thank you to Robert and Jack. I know Jack had to leave early, but this is amazing. Feel free, please. I'm sure Robert and Jack would love to connect on LinkedIn. I put a link in the survey, a link in the chat to our survey if you want to continue to be notified about future events like this or be part of our group, or if you're interested in speaking, we're always looking for speakers like this. Robert, do you all have this like on GitHub or something, or is this still?
It's this whole product, our project is open source. We do have it on GitHub. We do need to do a little bit of cleaning up before we release the code. So we can work on that now. But if you're interested in using the code, before we do that, just reach out to me. I can certainly invite you to our repo right now, and I'll walk you through the mess that it is before it's ready to share widely with the world. But happy to share. So just reach out to me directly.
Yeah, and I'll once the recording's done, I think I talked to Melissa. We'll post this on LinkedIn as well, the recording, and then we can put links in there too. Like if you have your GitHub, we can link to your all's LinkedIn profiles if people want to connect with you. But yeah, this is amazing. I know it'll be really useful, not just for comp matching, but I just, as you were talking, I was like, could think of so many use cases in HR. So
Absolutely.
Thank you, everybody.
Thanks.
Thank you. Have a great weekend.
Take care.
Bye.
Thanks, Robert.
Bye.